Science is all around us, even in a simple glass of water. Have you ever tried to make a sweet drink by mixing sugar into water? Sometimes it seems to take forever for the sugar to disappear, doesn't it? Well, today we are going to explore a super cool experiment, just like one I might do with my students. We're going to investigate a simple secret that makes things dissolve much faster. It's a trick you probably already use without even thinking about it. This experiment is all about putting that trick to the test to see how it works and why it's so effective. Let's get ready to make some science happen. The main goal, or what we call the aim of this experiment, is really straightforward and easy to understand. We want to find out if stirring a mixture helps a solid like sugar or salt dissolve more quickly in a liquid, like water. Does moving the water around with a spoon actually speed up the process? Or does the sugar dissolve at the same speed whether we stir it or not? By doing this experiment, we can see the answer with our own eyes. It's a hands-on way to prove an important scientific idea about how substances mix together to form a solution. This investigation is a wonderful example of how science helps us understand our everyday world. Think about making hot chocolate, lemonade, or even just adding salt to your soup. You often stir it, right? But why? Science has the answer. By comparing two different situations, one where we stir and one where we don't, we can gather evidence. This evidence will help us make a strong conclusion about the effect of stirring. It's like being a detective, looking for clues to solve a mystery. In this case, the mystery is the secret to faster dissolving. So, let's put on our imaginary lab coats and get our scientific minds ready for action. This experiment doesn't require any fancy equipment, just some simple things you can probably find right in your kitchen. It's safe, it's fun, and it teaches us a fundamental concept about chemistry called dissolution. We're going to observe, we're going to compare, and we're going to learn something amazing. Are you ready to dive into the world of solvents and solutes? Let's begin my stirring experiment and uncover the secret together. Consider this. Science is cool. First things first, let's gather all our materials. For this experiment, you don't need a high-tech laboratory. You will need 2 clear glasses or beakers of the same size so you can easily see what's happening inside. You'll also need some water, preferably at room temperature, to act as our solvent. For our solute, the substance we are going to dissolve, you can use 1 tablespoon of sugar or salt. A measuring spoon will help make sure you use the exact same amount for both glasses. Finally, you will need a teaspoon or a stirring rod for stirring and a stopwatch or a phone to time the experiment. That's it. Simple, right? Now, let's get to the procedure, which is the set of steps we will follow. It's very important to follow the steps carefully to make sure our test is fair. First, you need to measure an equal amount of water and pour it into each of the 2 clear glasses. Using the same amount of water is key. Next, get your stopwatch ready. At the exact same time, add 1 tablespoon of sugar to each glass. Make sure the amount of sugar is identical in both glasses. This step is crucial for getting reliable results that you can trust. Here comes the most important part of our experiment, the part where we introduce our variable. As soon as the sugar is in the water, start your stopwatch. In 1 glass, which we can label glass A, do absolutely nothing. Just let it sit there and watch what happens. In the other glass, glass B, you need to start stirring immediately with your spoon. Stir it gently but continuously. Don't stir so fast that you splash water everywhere, but keep the water moving around the sugar crystals. This is the only difference between our 2 glasses. The final step is all about observation and timing. Keep stirring glass B and keep watching glass A. Your job is to time how long it takes for all the sugar to completely dissolve in each glass. For glass B, you'll stop the timer as soon as you can no longer see any sugar crystals at the bottom. For glass A, you will do the same, but it will likely take much longer. You need to watch it carefully until every last crystal has vanished into the water. Record the time for each glass separately. As you conduct the experiment, you will start to see some very interesting things happening. In glass A, the glass that you are not stirring, the sugar crystals will sink to the bottom and just sit there in a pile. You might see the water around the pile get a little bit cloudy or wavy as some sugar slowly starts to dissolve on its own. However, the process is extremely slow. The sugar particles at the very top of the pile dissolve first, but they create a concentrated layer of sugary water that sits right above the pile, blocking the rest of the sugar from the fresher water. It's a very calm and quiet process. Now, let's turn our attention to glass B, the one you are actively stirring. The difference is like night and day. As soon as you start stirring, you create a mini whirlpool or a vortex in the glass. This motion lifts the sugar crystals from the bottom and sends them swirling throughout the entire volume of water. Instead of sitting in a pile, the sugar particles are constantly moving and coming into contact with fresh parts of the water. You will see the crystals getting smaller and smaller much more rapidly until, poof, they seem to disappear completely. The entire process is full of action and happens much faster. The numbers on your stopwatch will tell the final story. When you check your recorded times, you will almost certainly find that the time it took for the sugar to dissolve in glass B, the stirred glass, is significantly shorter than the time for glass A, the still glass. For example, the sugar in glass B might dissolve in under a minute. Meanwhile, you could be waiting for 5, 10, or even more minutes for the sugar in glass A to fully disappear. This big difference in time is our key piece of evidence. It's the data that will help us form our conclusion. This observation is the heart of our discovery. We saw that with all other things being equal, the same amount of water, the same amount of sugar, the same temperature, the simple act of stirring made a huge difference. The visual evidence of the swirling sugar in glass B compared to the static pile in glass A is very powerful. The quantitative evidence from the stopwatch confirms what our eyes told us. Science isn't just about reading facts in a book. It's about seeing those facts in action. And that's exactly what we have just done with our simple but effective experiment. So what is the grand conclusion from my experiment? It's simple and clear. Stirring helps a solute, like sugar, dissolve faster in a solvent, like water. Our results showed this without a doubt. The sugar in the stirred glass disappeared in a fraction of the time it took for the sugar in the unstirred glass. By moving the water around, we dramatically sped up the rate of dissolution. This isn't magic, it's chemistry in action. The mechanical action of stirring makes a huge impact on how quickly a solution can be formed. It's a scientific principle you can now say you've proven yourself. But why does this happen? Let's think about it. For sugar to dissolve, its tiny particles need to break away and mix with the water particles. When the water is still, the water right next to the sugar pile gets saturated, meaning it can't hold any more sugar. The stirring action, however, is like a traffic controller. It moves the saturated water away from the sugar crystals and brings in fresh water that has plenty of room to grab onto more sugar particles. This continuous mixing ensures that the undissolved sugar is always in contact with unsaturated water, allowing it to dissolve much more efficiently. Let's answer a few common questions to make sure we've got it all down. First, what was the aim of the experiment? The aim was to determine if stirring affects the speed at which a solute dissolves in a solvent. Our simple goal was to see if stirring makes things dissolve faster. Second, what was the independent variable? The independent variable is the one thing we changed on purpose to see its effect. In our case, the independent variable was the act of stirring. One glass was stirred and the other was not. Finally, what things were kept constant? These are called controlled variables, and they are super important for a fair test. We kept several things the same for both glasses: the amount of water, our solvent, the amount of sugar, our solute, the temperature of the water, and the size and shape of the glasses. By keeping all these things constant, we can be confident that the only reason for the difference in dissolving time was our independent variable, the stirring. And that, my friends, is some excellent science.